All right, we're recording.
Oh yeah, you got it. Oh, cool. Cool. Okay, so I'm going to start with the part. So one thing that I've struggled with is knowing what order to present this stuff in. So I'm going to start at the part about merging chains, and maybe we'll go off on other interesting parts later on. So, or maybe just for the sake of getting it in the recording, this is the abstract that I submitted. So basically the first sentence is the main idea. So like people are talking about how to build sharding into blockchains, and I'm going to try to flip it around and say sharding isn't something we need to build into blockchains. It's something that we naturally already have because we have more than one blockchain. And so we can think of those more than one blockchains as shards of a piece of shards of a larger single state. So like if we restrict our vision of blockchains to be only Bitcoin and Litecoin just for a second, we can think of those two chains as two shards that, when taken together, represent the total state of the Bitcoin, Litecoin, like multi-network, multi-consensus. So we've seen how forks can happen in the wild. We've seen like there's this consensus around what Bitcoin is, and then later people wanted to change things about Bitcoin, and so now we have Bitcoin and Bitcoin Cash. And I'm saying we can think of those as two different consensus metagames, but there's still only one underlying, like I'm calling it a labeled transition system here. So let's talk about chain merging. So a blockchain, I've put it in quotes because I don't know quite the vocab that I want to use yet, but it's basically some labeled transition system plus some consensus game that happens over that labeled transition system. So in general, you can imagine like your labeled transition system, you might take different traces through that transition system, and we need to be able to say like, this is the real one. Here's what canonically happened. And that's what the consensus game is for. And just like Michael was saying earlier, like not everyone has to have the same view of what the real state is, like the Bitcoin and Bitcoin Cash communities have different divergent histories. So let's consider some simple ones here. And these two LTSs are a lot simpler than a Bitcoin is, for example, because with Bitcoin, you have infinitely many states where, the states would be like Alice has one token, everybody else has zero. And then another state is Bob has one token, everybody else has zero. And then another state is like Alice has one and Bob has one and everyone else has zero. So you can see quickly how there's infinitely many of them. But for simplicity's sake, I'm considering these two transition systems. So in LTS1, we have two states, capital A and capital B. We're going to start in state A. That's what the blue arrow is. And two valid transitions, which I've named little a and little b, and they tell you which state you're going into. So if this were a blockchain, basically the blocks would look like this. First we did a B, then we did an A, then we did a B, then we did an A. And if your consensus metagame allows you to aggregate transactions like Bitcoin's does, then maybe you'll have like a B and an A in the same block there, or maybe it would be like BA, BA. But the point is we're going back and forth. Those are the only transitions you can make. And then the second labeled transition system is really similar. It has three states, X, Y, and Z. We're going to start with X, and it has, again, three transitions. Like we can go from X to Y, Y to Z, and Z back to X. So sort of we can think of these as like Bitcoin on the left and Litecoin on the right, or whatever blockchains you want to think of. And I noted that these are like not super interesting individually because actually they're deterministic. Like if you're in state B, there's only a single valid transition that'll take you back to state A. And that need not be the case. Like we could have two different labeled transitions that take us back to state A, or we could have more states where there's different ending states we could go to, or like there could be a loop that goes from B back to B itself. But for now, I'm just considering these like dead simple ones. So now we can construct a single labeled transition system as the outer product. There are 2 times 3 equals 6 states. That's because there were 2 states in the one and 3 states in the other. So now there's 6 states here. And so I've called them like AX, BX, AY, BY. And basically what this top left state here means is that the first labeled transition system is in state A and the second one is in state X. So we can think of our entire labeled transition system of being in state AX. Mm-hmm. So this would be equivalent of saying like, okay, the current state of Bitcoin is these token balances, the current state of Litecoin is these other balances, and so the combined state is the state that you get by gluing those two together. That's your AX.
It's kind of like a disjoint union of the labels, or the states and the transitions, or the states and the labels, I guess, maybe.
Exactly right. Yeah. And so I put this blue arrow on AX because the starting states, the blue arrows were on A and on X. And so we can do that for any blockchain we have. And one thing that I haven't stated here, but that is coming up now, is like, you have to have some starting state. So like with Bitcoin, the starting state was nobody has any tokens. And then we just get them by mining. Or like in our chain, the starting state, or I don't know if this is strictly true, but it's something really close to true. Like the starting state is there's nothing in the tuple space. It's just empty. Okay, so great. So we've still got all of our same transition labels that we had before. Given a particular A state, you can make an A transition. Oh, haha, I labeled my little A and B transitions opposite here, but whatever. So like starting in state A, you can make a transition that takes you over to the corresponding state B, but like this little A transition is never going to take you down to like BY, because that would also alter the state of the second labeled transition system. Oh yeah, okay, so the columns are congruence classes as far as that first LTS is concerned, and the rows are congruence classes as far as the second one's concerned. So like people who care primarily about this labeled transition system with just A and B, they don't really care whether they're in AX or AY or AZ. Those all look the same to them. And likewise, BX and BY and BZ, because they, you know, don't know or don't care that that other LTS even exists. So we can do that with as many LTSs as we want. Just join them together as outer products, and here we go. So when a new group of users comes along, and they care about both chains in some sense, maybe they hold Bitcoin and Litecoin, or maybe they care whether we're in A or B, and they care whether we're in X, Y, or Z, they can create a new consensus metagame that uses the full LTS, not just one of the two parts of it. So for whatever reason, I was invested in both of those. And in this case, I mean invested like, you know, in terms of mind space, or like I cared about them. But if we're talking about actual money, then it could mean like I actually held value in there. Oh yeah, right. So now once we're using this full LTS, now it's not deterministic anymore. Like we could start in that top left state, AX up here, and we could make a transition that's like BYZA. So let's see where that takes us. We go, and now I specified them the original way. So we go BYZA. And so it gets us back down here to state AZ. A different thing we could do is we could go YZBA. So that would take us down YZBA. And so what we saw there is that we made the same transactions. There's an A, a B, a Y, and a Z in every one of these. The order actually didn't matter. We ended up at the same final state, AZ. And so what we can say is that these traces, this one here and this one here, commute with one another. And so to go back to the like Bitcoin UTXO DAG that I drew earlier, what that means is that we don't need to establish a total ordering over these. Either one is equivalent. Yeah, so this is what I was just saying here. Oh yeah, or actually more particularly, like these both ended with A, so that's not the interesting part. So what we really noticed was that a B can commute with a YZ. So here in the second one, we had the YZ first and the B second. Okay, so an example DAG could look like this. Maybe there's some people who only care about the XYZ state, and so they're starting to build this, or the XYZ LTS. So they're starting to build this blockchain where they do a Y, then they do a Z, and you know, maybe some separately, simultaneously, or earlier or later, we don't care or no. Someone who only cared about the first LTS does a B transaction. So that takes them from the starting state of A over to the next state of B. But now here comes along someone who's playing both games, someone who cares about this more complex, complete labeled transition system. And so they build a block that uses both as parents. We've taken this YZ and we've also, someone else took this B transition. And so now they decide, this person who's playing the larger consensus metagame, caring about both chains, decides to take a transaction A. So let's see what I wrote here. In this way, we see that there's really only a single transition DAG. So I'm trying to use the word transition instead of transaction because for one thing, it evokes labeled transition system. And for another thing, it gets around all the nastiness that our chain got into about what is a transaction. So here's our single transition DAG. And what I'm going to try to say is that anyone can build any block on this DAG anywhere they want with whatever parents they want. Imagine it almost like, oh, it's actually maybe in some ways similar to what Michael was saying about like just having this message board where transactions come around. But basically like anyone who wants to can come in here and say like, okay, given this A transaction or transition, I'm now going to create another one called W. And it's like, well, dude, what the heck is W? We looked at this complete thing up here. There isn't a W anywhere in there. And all that that means is that whoever built this thing, this W transition, is playing, there's more transitions on there, and whoever's built this W one is playing in a consensus metagame where W transitions are allowed. Now, it may be that people in that AB system don't know or care about W transitions, and the people in the XYZ system don't know or care about W transitions. And all that means is that this transition here, this W transition, that's going to be orphaned off in their consensus metagame. Of course, W is invalid. It didn't even appear in their labeled transition system in the first place. But anyone's free to still build it on there. So what I'm trying to get at is thinking of a single DAG of all the transitions that have ever been made. All of the Alice pays Bob a Bitcoin, all of the Charlie bred a new CryptoKitty, all of the Dave voted in this election, all the stuff that we care about in blockchains. Think of it as a single DAG of transitions, possibly disjoint. And in general, or like at least in, you know, in my reality, they are disjoint because Litecoin and Bitcoin don't crosstalk right now. So, you know, there could be other stuff going on over here, W, Z, like, you know, who even knows what it is, trippy stuff like Omega. Like, we don't even know what those are. They're just a separate disjoint part of this same DAG. And for those of us who only care about the two labeled transition systems and their outer product that I've introduced so far, we don't come to consensus over this left part. Okay. So then I say, new metagames can still add additional transitions. And then my side note is really add isn't the right word. It's more like they allow them. Let's just assume that all possible transitions exist, and it's only a question of which ones are allowed or enabled in a particular consensus metagame. So there might be people who are playing this consensus metagame who care about labeled transition system 1 and system 2, and they're saying like, hey, we can do interesting things beyond just gluing them together. We can actually add in new transitions, or like, again, I keep saying add, but a better word is like allow different transitions. Because you can imagine me drawing multiple arrows between any states, adding in all of the other arrows. And so in this example, I've just added Q and W in here. Q is an interesting one because Q allows you to undo a Y. That wasn't allowed when we were just playing the regular XYZ system. Only going from X to Y, Y to Z, and Z back to X is allowed. But now there's some new consensus metagame that says like, oh, I dig these states. I like what you guys have done here. Let me just make a little modification where I allow this new Q transition. So you could think of that almost as like, hey, I like Bitcoin. I see what you guys are doing there. Let me now like enable this transition that allows me to burn some UTXO and actually restore a previously spent UTXO. You know, maybe that's what Q represents here. And W is interesting in an even different way because W takes these two LTSs, you know, the AB one that's in the columns and the XYZ one that's in the rows, and it gives us this atomic transition that does, you know, a move to the right and a move down, but as a single transition. So that way we know that you're not ever going to accidentally get consensus over just the move right or just the move down, but they happen together as a W. Okay, so let's see. So there's a lot of interesting ways to classify consensus games. We've talked about a bunch: proof of authority, proof of work, etc. You know, like single person makes all the rules. But now we can also classify these consensus metagames by which transitions are allowed. So if we think of this like this labeled transition system, and we've seen already that I've only drawn parts of it. Like even now that I've added in Q and W, that's only part of it, because there might be other people playing other games who have this transition, you know, or a different like Y prime transition, or they might even have crazy stuff that like, you know, has whole different states or whatever it is. So we can start to classify these as like this Venn diagram. And so the very first two labeled transition systems that I represented or that I presented are these two innermost bubbles. Like the one just had A and B transitions, the other one just had X, Y, and Z transitions, and they didn't actually have any transitions in common. They were totally disjoint. That's why this middle area is empty. And then I presented this one that glues them together. So that's this pink circle here. It contains both AB and XYZ, but it doesn't contain anything beyond those. That's why this region is shaded as empty. And then there's this one that we presented, which adds in Q and W, and so we have Q and W over here. And so the idea is, once we're thinking of this single global labeled transition system, we can put consensus metagame circles anywhere we want on here. Maybe I'm interested in some little portion of this thing that allows XYZ, and it also allows me to have that undo one, Q, like this. And so we can form our consensus metagames over whatever subset of all the transitions we want. So maybe I'll just pause there for a second.
And I have a question. So where this W will be stored? It's not part of the LTS1 or LTS2, right? Because these networks will say this is not a valid block and we will delete it or whatever. So you have a new LTS, right? LTS3, which contains these changes.
Yeah, I think I only heard most of that, but your question was like, where are these transitions going to be stored?
Yeah, exactly.
Yeah, that's right. Okay, so you can think of this global DAG. So let me actually switch back over to the thing I was showing earlier, which was this one. Get rid of that. Come back to this one. Okay, so here's some transition DAG, right? This one we happen to draw based on like a pi calculus or row calculus kind of model where we have COM events and stuff. And so let's just say, like, for whatever reason, Tomislav, you and I are playing this metagame that it's basically our chain, let's say, or it's basically pi calculus, but for whatever reason, we've decided there are not going to be valid comms over some particular channel, like the yellow channel. So you and I are playing this game that's identical in every other way, but we're not allowing comms over the yellow channel, right? Now, this whole DAG still like exists in the sense that that information is out there and was published. Whoever made this yellow transition set it out across their gossip network. All their peers heard about it. Maybe even you and I have heard about it. We happen to not consider this a valid block. So we have some options now. You know, if we're just like loaded, wealthy with disk space, maybe we'll keep it around and just know it's not valid, or more likely we'll just prune it and not store it on our disks. But whoever's playing this more general consensus game with a bigger circle in the Venn diagram, they will keep that block around in their disks. So I'm imagining it as being like the people who care about it, either because they've gotten consensus over it or because they want to or care about it for whatever reason, they'll keep it on their disks. But the people who say, well, that's not a valid transaction, they're going to discard it just like I would discard a Bitcoin transaction that creates more coins than it consumes.
Yeah, this makes sense. And you need this larger network. They can work in two modes, right? You can say I will be validator on both networks and this my third network, or I can just use information from existing network and I will just validate this bigger network without holding all the information from this first two networks, right? Is it really necessary to have all of this information?
Oh, okay, yeah. So that's a good question. Like you're saying, is it necessary to have all of the transitions all the way back to whenever each?
Can you be a read-only node for red ones and blue ones, and real validator for these yellow ones?
Yeah, so the concept of read-only node is a little different. So like I take read-only node to mean I'm not playing the, so far you would say like I'm a read-only node in our chain or I'm a read-only node in Ethereum. And what that means is I'm syncing, I'm confirming that all of the transitions were valid, I'm participating in the gossip protocol, but I'm not playing any consensus metagame. And yeah, so like that's still a valid, so like I guess I'm just trying to generalize the notion of read-only to like what consensus games am I playing or not playing. And it might be the case that I'm not playing anything, I'm just syncing a bunch of blocks and helping people gossip blocks. Or it might be the case that I'm playing in like 2 or 3 of these consensus metagames and helping gossip blocks in a couple others. Or it might be that I'm playing 3 of them and I only care about those 3, and any other blocks I get I just discard because I don't consider them valid.
And then of course you must be careful to not use this yours network and send some information on this existing network, because this is not a valid block anymore, right?
Well, okay, so let's try to I'm trying to deconstruct the idea of network. So like, let's go back to this one. I think I think what you're saying is basically right. I'm being pedantic about vocab in the same way that like Michael didn't like the term tokens, I guess. So I'm trying to separate network into 2 parts. There's the labeled transition system, which is like the runtime, and then there's the consensus game. So I'm trying to say like there's only a single DAG of all of these transitions that we've made through the labeled transition system. So like this was the example DAG that I started to draw here. So, if we want to make one of these blocks that only we consider valid, it's still sort of like, it still references a parent pointer here in some other part of the DAG, or, or maybe it doesn't, maybe it's totally disjoint. But it all goes into this one single DAG. And then the question is like, if you're running a node, a blockchain node, you're making a decision about which blocks you choose to, first of all, consider valid, second of all, gossip to other people, and third of all, form consensus over. So right now, if you're a Bitcoin miner, you're basically making the same decision in all 3 of those criteria. Like if a block is not valid, you're not going to gossip it to other miners and you're not going to include it in your blocks. But in this more generalized framework, you might say like, well, I don't consider this thing valid, so I'm not going to come to consensus over it, but I know there's a lot of other people who do, and I have some free bandwidth, so I'll go ahead and gossip it. So I'm basically like a read-only node in their consensus metagame. I'm still going ahead and gossiping to help facilitate their network, but I'm not going to come to consensus over this Omega block because I don't have Omega transitions enabled in my consensus metagame.
Do you think that the network could be attacked by there being like allowing pretty much any nonsense almost in the chain? Like if you're not aware of the other chains.
Yeah, that's what I'm kind of starting to wonder. Like if somehow my node starts like talking, like can my gossip network get like DOSed by people just gossiping in all kinds of stuff that's not valid in my metagame? I think that's an interesting question. I'm like, how does Bitcoin handle that? Have people tried to just gossip like a bunch of bogus junk to Bitcoin nodes? What do they do about it?
Well, Bitcoin is almost like undosable because you'd have to DOS every single validator. But the difference is that, they don't allow it into the transaction pool, versus this would allow pretty much anything actually into the storage, right?
Well, I see what you're saying. So like, yeah, you definitely, yeah. So like, let's say we're playing some consensus metagame that cares about some portion of this overall DAG, which I think is usually going to be the case. Like, I don't think that nodes should actually store each one of these. So like if we're playing some game that doesn't consider the yellow blocks valid, we should just discard them right away. We probably shouldn't gossip them unless we know we're gossiping them to like someone who does consider them valid and we want to do that service. So yeah, I'm thinking the same thing. Like for every consensus metagame you play, you have some set of transactions that are valid and you're maybe willing to come to consensus over them. And so you'll keep those in your transaction pool, but the other ones you'll throw away from your own like local disk space or memory.
Okay, yeah, that's cool. I think I see that.
So I wanted to ask about the rules for determining validity and kind of how it relates on the different levels of the consensus metagames that are going on here. So there's, it seems like there's naturally some sort of hierarchy of label transition systems that you're creating and kind of, I don't know, highest or lowest level, whichever way you want to look at it. I'll say at the highest level, using the label transition system that incorporates all of the blockchains that currently exist, that ever will exist, you know.
Yeah.
How do you formalize the consensus rules that are used for all of the blockchains that exist and ever will exist? And how do the like you're trying to determine validity of transitions in these kind of sub DAGs or sub label transition systems, and how does determining that validity relate to the original rules that we have on like the highest level label transition system? I don't know if that's a clear question or not.
Yeah, maybe. Let's try to think through it. So like,
yeah.
If okay, so I see what you're saying. Like we kept making this thing broader and broader, right? And then maybe there's some other new chain that has a couple more states, and so we put it in as another piece of the outer product.
Yeah.
So I guess, Mike, is your question about like the person who's saying, I want to consider every transition that I've ever heard of so far valid? Or, the person who says like, I love Litecoin and Bitcoin and Ethereum and names 20 of these things that they've heard of and wants to play on them? Or is it more of like, I want to consider absolutely everything that has been and will be valid?
Well, so I guess all I'm asking is, once we've built this labeled transition system that encompasses all blockchains, let's say, we need some sort of consensus metagame on that labeled transition system for it to kind of qualify as one of these structures, right? So what are the rules for that consensus metagame on the highest level structure, and how does that compare to kind of the substructures that exist, or whatever?
I feel like it gets into the diagonalization theorem about with like Cantor's sets on sets.
Mm-hmm.
But
I guess I was going to think of this in terms of like, there doesn't necessarily have to be a consensus metagame that anyone's playing over the entire DAG. It may well be that like, we can think of this this LTS as something interesting, but nobody cares about both chains. And so there's people who are only playing this one, and there's people who are only playing this one. And it need not be the case that anyone's playing over this entire one.
Mm-hmm.
So it doesn't have to be. So like, even as we draw up these DAGs like this, where we're saying, so here's what I want to tie together these two pictures. Like there's this one that I'm thinking of more as your traditional like blockchain or block DAG. And then there's this one that's more like a labeled transition system.
Mm-hmm.
So every time I go out to interact with a blockchain in some way, basically I want to specify, here's my starting state, AY, and here's the transition that I'm making, Z. So the way you do that is by building a block on one of these DAGs. So let's say I'm the person who's building like this Omega block right here. So the way I specify my starting state, in this case, my starting state is Z, and I specify that by building a parent here. And I'm saying like, okay, every parent recursively from this parent pointer that I'm building right here, once you replay all of that, that gives you my starting state. I started in AX, then I made a Y transition, that took me to AY, then I made a Z transition, that took me to AZ, and now I'm gonna make an omega transition. So I specify my starting state by specifying parent pointers, and I specify my transition explicitly by writing it as omega here. I don't remember why I was talking about that. But I think it's an interesting distinction, at least.
Yeah. Okay. So I think I see what you're saying though, and it sounds like we don't really need a consensus metagame over this, universal labeled transition system, or whatever you want to call it.
Right.
Really, we just need to have some sort of validity judgment on transitions in kind of like particular implementations or particular instances of these labeled transition systems.
Yeah, yes, exactly. So I'm thinking of it like when we go to, let's say we want to start some new consensus metagame, we have to specify all of the consensus stuff that we've talked about all along. Is it proof of work or proof of stake? Who are the validators? What's the block time? Can we aggregate? All of that. And then we need to specify what transitions are we considering valid, or like what, out of this entire labeled transition system that we know about, maybe there's parts we don't even know about, but in as much as we know about this, which of these transitions are valid? And then that's what we need for the metagame to start.
Yeah, cool.
But just to be clear, we do still need some kind of like top level or how are you getting the validation from like, if you're merging Bitcoin and Litecoin, how do you get the validation of Litecoin on the Bitcoin network?
Oh yeah, okay, yeah, great question. So let's go back to here. So like, let's say we've got Bitcoin on the left and Litecoin on the right. It's not that we're going to get either one of them to be validated on the existing networks, right? Because the Bitcoin rules are we only consider A and B transitions valid, and the Litecoin rules are we only consider Y, Z, and X transitions valid. But what we might do is we might say, hey, we're a group of people who likes both of these. Let's come up with this more general game that allows us to consider both of them valid. So that's this one here. So there's still the original Bitcoin miners. There's still the original Litecoin miners. And now there's us, the people who care about both, who are playing on this game here. Now, it might be that someone who was a Bitcoin miner says like, oh, that's cool, and I also care about Litecoin, so I'm going to join this new game. And it might be that every Bitcoin miner says that, and then it's more of just like, hey, this just looks like a hard fork where we're suddenly going to allow all the Litecoin rules to come and be valid as well.
Yeah, I'm wondering if like, so this meta consensus group, are they revalidating both the Bitcoin and Litecoin chains, or are they more just like taking reach to be consensus?
Yeah, I see. I understand your question now. So here we are, we're going to play on both. Like we need to know what our starting state is, right? Where are we going to start? So our options are like our first block can use the latest Bitcoin block and the latest Litecoin block as a parent. And then in that case, yeah, we have to validate all the way back to Genesis. And that is definitely not, this is when I first presented multi-consensus a while ago, thinking of it as just like two Casper instances over the same row VM, that was the thing that I think Tomislav said, and that's a real concern. Like if you've got two blockchains that have 10 years of history and now you want to merge them, that's a crap load of validation that you have to do all the way back. Yeah. Now, it might be that you were already a Bitcoin miner and so you've done that. Or it might be that you were already both and you've done that, but yeah, everybody in the new game has to come to consensus over the starting spot, and that might be really expensive.
Yeah.
Is there something wrong with kind of just taking the validation that's already done on both of those networks and using that?
Oh yeah, I mean, right. Totally not, but you still have to like sync the chain basically. like you're saying, like there's been Litecoin miners around all along. Let's just look at what's the longest chain with the highest proof of work and start there, right? Is that what you're saying?
Yeah. I guess what you're saying is that you still, or that you're still trying to build the actual like data itself, like rebuild it and kind of zip up the two chains all the way through history.
Yeah, I don't know. That's a good question. So I don't know if we have to zip it. Let's go down to the bottom and experiment with this a little bit, actually. So let's say we have like, here's some Bitcoin blockchain. And maybe, you know, probably there's a couple of orphans along the way in there. And then here's some Litecoin blockchain. And it might have some orphans too. And so our consensus is going to look like this. So here's the Litecoin rules, here's the Bitcoin rules, totally disjoint, and then here's our rules. We're going to be green. And just because I had to draw it, there's this space that's in green that's not in pink or blue, but like we're not allowing anything new in there. It's just like we're allowing Bitcoin and Litecoin transactions both valid. So here we go now. We come along and like, you know, maybe at first I'm even just doing a kind of normal Bitcoin thing. Like it's perfectly normal or perfectly valid for me to just, you know, transfer Jay a couple of Bitcoins and then transfer Tomislav a couple of Litecoins. But at some point I might want to do something that, you know, incorporates both of those. And then maybe a blue person comes. Oh, so this is another interesting thing about it. Like if this green block contains only things that are valid in Litecoin, like there's no Bitcoin transactions in there, then regular old Litecoin only miners can come along and build on that as well and be like, you know, I know this guy plays some weird game where he does Litecoin and Bitcoin, but in this particular block, he only did Litecoin and I consider those valid. So I'm going to go ahead and build on it. So we can have more like normal blue blocks coming down here. And then another one of these like merge blocks, something like that.
Yeah, so I guess that's kind of one thing I was getting at with my earlier question is, so on one of these, say like the Litecoin, so we're talking about the blue chain here. On one of these kind of self-contained label transition systems, like you have some set of rules, right, that you're determining your allowable transitions by. And on another system like Bitcoin, you have some different rules or whatever. Anytime you move to a higher level, like one of these metagames over, you know, one or more, you have to be working with like a less restrictive set of rules, because it seems almost like here you're saying like an allowable transition for the green stuff is like it could be anything from Bitcoin, or it could be anything from Litecoin, or it could be this other thing maybe.
So Isaac, by other thing you mean like maybe we actually do have some additional transitions out here in the green part, like that are not allowed on Bitcoin or Litecoin, but we're allowing on our chain.
Like if you want to combine Litecoin and Bitcoin somehow, right?
Yeah. So burn 2 Litecoin and issue a Bitcoin or something.
Sure.
Yeah, right.
Yeah, so I guess my what I was going to say is like, so any transaction on one of these, like the Litecoin or Bitcoin network, is like almost automatically valid in this higher level meta consensus game that you're playing. But anything you do on the meta level is not necessarily valid on the lower level.
Yeah, that's exactly right. Yep.
Cool.
Oh, so one way we drew this at one point was by actually, so the color of the block is like indicates what transactions are considered valid, and the color of these little lines indicates like what portion of our Venn diagram they fall into. So we might do something like that. Oh no. Oh yeah, that's perfectly valid, I guess. Well, it seems silly to draw one perfectly in line with the pink ones that's actually also green, so I'm not going to do that. But yeah, we could have something like this. And yeah, right. Like even though this block was green, which basically means like the person who created that, well, actually, let's think about what does that mean? The very fact that I'm putting multiple little dashed lines inside each block means I'm apparently allowing transaction aggregations in my consensus metagame. And I guess like the fact that this block is green just means that whoever signed it, like the miner who mined it, you know, acknowledges that they're playing by these like more lenient rules. But the fact that there's only blue transactions in there means that a Litecoin miner will still see that as valid because those transactions happen to be still valid within the Litecoin rules.
Yeah, I think as long as you make the general rule, like when you're playing a consensus metagame, you know, above one or more already existing label transition systems, that like if you only have, you know, transitions or whatever from one particular system, then your rule should be consistent with that, even at the meta level.
Yeah, right. So one little thing that I want to throw in here though too is that it's not only green that's a consensus metagame. Bitcoin mining is also a consensus metagame, and Litecoin mining is also a consensus metagame. And the reason I'm using, you know, and maybe that's not the best term, but the reason I chose the term meta is because there is ultimately a single underlying transaction DAG, which is like what I was trying to illustrate here. So maybe these pink, you know, the colors changed, sorry. Maybe these pink ones are Bitcoin and these yellow ones are Litecoin up here. And they're totally disjoint, but they're still part of that same one transition DAG. And then the meta part is consensus. The Litecoin miners are saying, given this ginormous DAG and a set of transitions that we consider valid, let's come up with our canonical version of the story. It happens to be this one that only contains the pink transitions. And then the Bitcoin miners are saying, given this exact same DAG that's circled in pink here, and our notion of what valid transitions are, let's come up with our canonical version of history. Now, obviously, the Bitcoin miners aren't going to come to consensus over these transactions. These aren't even valid Bitcoin transactions. Those are just Litecoin transactions.
But Bitcoin miners will not see these other transactions, right? These other blocks.
Given the current implementations of these blockchains, that's correct, because like Litecoin miners are not going to be bothering gossiping their blocks or their transactions to people who they know are not going to consider them valid or find them interesting.
Mm-hmm.
But you know, at a sort of different level, like there's no reason that's impossible. If I'm a Bitcoin miner, I might also like, you know, go on to some Litecoin block explorer and now know about these transactions, or I might run some custom node that like still receives their gossip or something. Like people don't do that because it's not useful, but it's not impossible.
Yeah, and then from minus on Bitcoin, this can look like an oracle, right? That can say something else which is not part of the of the chain, right?
Yeah. Oh, okay. So yeah. What's the oracle part?
These other chains, or this the bigger chain, because you are not care about this information. You're not validating the chain, but you get some information outside your chain.
Yeah, so I think that's basically right. The language that I'm trying to think of it in terms of though is like that there's a single underlying DAG. A Bitcoin miner might hear of a different transaction built on this DAG that doesn't make any sense, that they don't consider valid, you know, because it was a Litecoin transaction. And so yeah, they won't include it in their storage, they won't mine it into their blocks, etc. But they, you know, they could still hear of it.
Mm-hmm.
I was thinking that maybe you will want to protect yourself with two chains, or I see this as we were talking about this. One of these chains can be your local network, your private network, right?
Yeah.
And you want to interact with other chains, and they don't know about your existence, but you can use it for like your consensus. That
yeah,
like you're playing your meta game with existing chains.
Yeah, totally. So like one of the things that I experimented with at some point is like, consider the public Ethereum network. Here it is. And then, well, I like to think about DAG-based ones better because it's more general. So like consider the public Archain network if it ends up being a DAG. So there it is. It's a public network, permissionless, all that great stuff we care about. And then meanwhile, here's some proof of authority network. It's private. Maybe banks own it, or maybe it's like just I own it and it's for my own personal use, but for whatever reason, it's not public. But you can imagine the situation where the owner or owners of the proof of authority network, while they don't want their stuff to be part of the general purpose public blockchain, they might want to incorporate data from the public blockchain into their chain. So like one way, but not the other. So the consensus rules then look like this. Here's our public blockchain. Here's our private blockchain. And, you know, a block might come along and do something like this, where it says like, yeah, we're building on all of our own history here from our private proof of authority network. But it's also worth noting that, you know, Thomas Love got 2 ETH here on the public network, and we're going to do something like that with that in our proof of authority network. Or, you know, maybe the blue one is like us here in Colab just having a poker game, and then the public network is Ethereum or whatever, and you know, we're going to wager some of our public tokens in this private poker game. It's not a public DApp. We don't want randos playing poker with us. It's just ourselves, but we want to use that same token. Mm-hmm. So we can use it as like a parent transaction. So another useful analogy that I've been kicking around in my head is if you think, oh yeah, so Isaac and I have this game Bitstory that we used for teaching high schoolers about proof of work, and it's the exact same consensus metagame as Bitcoin, but the runtime logic is totally different. There's no tokens or anything like that. All you're doing is adding words onto a story. So like in each block, you add a word to the story. So I was almost thinking about this as like different people playing Bitstory, and like over here on the left side, this is like Harry Potter world. And then over here on the blue side, this is like Star Wars world. And there's always this question of like, what is canonical in the Harry Potter world? Is this little piece of fan fiction canonical? Most people probably don't think so. So it got orphaned off. And then like maybe there's some crossover episode where like, you know, Harry fights against Darth Vader or whatever. It's like, is it canonical? You know, apparently it's not in mainstream Harry Potter world or in mainstream Star Wars world, but if there's people who care about it and care to write the sequel, then in some sense it's real. That's just a different consensus metagame. Kind of a silly analogy.
I'm very happy it came back to Bitstory. Sorry.
Yeah. Oh, yeah. Good. Bitstory is pretty useful, you know.
Yeah.
Do you really need to store the whole chain? For example, if you just want to, you know, confront Darth Vader with someone for Harry Potter, you don't need the whole chain, right? All of the red ones, for example. You can just use this path to the Genesis, or maybe.
Oh, I see what you're saying. Yeah, like if I'm someone who cares about this block right here, like I don't need to store this one probably.
Yeah, or something that is.
Or you're saying like maybe we don't even need to store these ones.
This is more evident if you have a DAG. And you are only in one branch, so this other branch you don't care about it. This is like
yeah, I see what you're saying. So let me see if I can illustrate what you're.
Because in this sense, this is orphan, but
yeah. So this, what I've drawn here so far, this is like the storyline of what Harry's done, but then maybe like concurrently, like Ron is doing something different over here, and. Oh, yeah. Oh, wow. Oh, so like if it never merges back. Oh, yeah, that's a really good question. So I think maybe, I don't know. So if it's Bitcoin proof of work, you're supposed to store all the way back to Genesis because you have to like figure out what the highest accumulated work is. And that's just how that consensus metagame works.
Wait, what was the question?
Because it is a chain. Sorry?
What was your question?
My question is, if you have a DAG, not a chain, then you can have different branches. And if you are referring to only one node in one branch, you don't care about this other branch. Because if you are not referring to any node in this branch, you don't really need it, right? You will have, for this branch, you will have all of this to the Genesis. But This other branch is something completely.
Mm-hmm.
So you're talking about maybe like these new pink ones that I just drew. If you're the person who's interested in this crossover episode, like you don't need to know all the other stuff that was happening concurrently in Harry Potter world over here.
Yeah. Only your chain in this game, right?
Oh, are you saying you would only need to store these blocks that like go on the path back to Genesis on the Harry Potter chain, basically, and you don't need to care about like literally all of the branches that are there?
Yeah.
Yeah, I think that's right. Like, oh yeah, we could even maybe have like a block at this point that merges back in with something that was relevant for the crossover episode, but later on, right?
Mm-hmm.
Yeah.
So is it possible to when you start playing this green game, right? Like say you want to build on the Star Wars chain first, and you have that first green there with the pink arrow pointing at it. Is it possible to just consider the blue block of it, maybe like that path all the way back to the Genesis, just as a single block that is your Genesis block for the green chain that you're now playing your consensus game in?
Oh, that's a good idea. So what we need, go ahead.
I just want to ask you, Isaac, what do you mean by consider only this node?
Well, so when you start a blockchain, right? Like everybody who's participating in that chain is going to agree on the Genesis block, right? So can you just make whatever the first block and maybe relevant information leading back to the original Genesis? Can you just make that your Genesis block for the chain you're building on now? Like, so in this green one, can I just make the Genesis block for this green one that blue block that it originally built off of, and then just go from there?
You're saying, Isaac, just like call this Genesis, or maybe one of our couple Genesis blocks.
Yeah, exactly. It's green Genesis or something. Yeah.
So I've really struggled with the concept of Genesis block, actually, even though it seems so straightforward, because so let's go back up to our transition system here.
Yeah.
So we can talk about a starting state, right? AX in this example. And then the blocks are transitions on top of that. So like from AX, I make an A transition to get to BX. So in as much as the blocks are, and like in Bitcoin, that's how it works too, right? Like the blocks don't contain all the token balances. They contain the Alice paid Bob, Claire paid Dave. So the concept
just the deltas, right?
Yeah, exactly. Yeah, the deltas. So I think you're onto something though. Like if somehow in our green consensus game, whenever we draw our labeled transition system, and if it's a system that's complicated enough to represent characters and fighting with lightsabers and stuff, like there's going to be a shitload of states in there, definitely.
Yeah.
But what we have to agree on is the starting state that we're in.
Mm-hmm.
But I think if we can do that, maybe every consensus metagame needs to explicitly specify a starting state.
Yeah, that's what I was wondering. And even if you want to say like this green game is going to build on both the pink and the blue, and like I'm starting at this pink block and this blue block, like the pink and blue block together will basically just be the Genesis block for the green game.
Yeah.
And Joshy, we were talking about this when you have like new Genesis, right? Which has a parent from the previous chains. Right?
Yes, we were talking about that. I think I even have some notes on that.
And you really you don't need to store all of the existing chain, but maybe later someone will ask you how did you get this hash, right?
Yeah.
Existing network, if this network doesn't exist anymore, you don't have the proof. But if this network already exists, you can just say, okay, go code to this network and find the Genesis. This another Genesis, right?
Yeah. Well, yeah. I mean, it sounds like if you believe that Bitcoin will survive, then you probably don't need to store the entirety of the history. You can just reference the block you started building from.
Yeah. Right. Oh, yeah. Okay. So I'm wondering if intentions matter a little bit. So like, if your intention is basically like, we're going to do this thing that merges Bitcoin and Litecoin, and henceforth only transactions that, oh yeah, actually that's exactly what you're saying when you start a new metagame. I guess I'm trying to decide, like, do you still want to interact with the regular old Bitcoin chain moving forward? You know, like as more just plain Bitcoin transactions come in and the regular old Bitcoin miners reach consensus over them, like, do we want to also include those into our merged chain? I guess at some point you might not even be able to, because like if, you know, so let's say we have the Bitcoin chain and the Litecoin and we do this merge thing. If I spend some of the UTXOs in the green chain, and then the regular old Bitcoin miners come to consensus over blocks that spend those same UTXOs in the regular old Bitcoin chain, then we won't be able to merge those particular blocks anymore because there'll be a double spend.
Wait, but are they the same UTXOs or are they different? Because you have green chain UTXOs and pink chain UTXOs and blue chain, right?
Yeah, good question. I think we need to investigate that a little bit. I don't know the answer.
Okay. That's kind of, I mean, this all kind of goes back to what I was asking about before, and you know, kind of the consistency of the consensus rules at different levels, and are there any constraints on that, or could you just literally say like, okay, I have some totally random set of transitions here and some other totally random set of transitions here, and they're just gonna interact with one another and be fine, or are there some sort of like constraints that we must impose on them for to get the properties that we want, you know?
Yeah, right. Okay, so let's think about a Bitcoin DAG. So we're back to individual UTXOs now at this point. So like, let's say this is some kind of Bitcoin thing. And then over here, these are like, I'm not even really, to be honest, 100% sure what I'm indicating by block color here yet. But by edge color, I'm indicating that these are Litecoin UTXOs and the pink ones are Bitcoin UTXOs. And then like, maybe some green thing comes along. So we know for sure, oh, maybe that's what color. Okay, so, I don't really know.
Is the color of the block not that it was validated by somebody in that particular network or something along those lines?
Yeah, so that's a good question. So at this point, they're not blocks though. At this point, they're individual transitions.
Okay, individual transitions.
Yeah, so like this, so I mean, I guess let's label them that way too. So like, I'll label it as a Litecoin transition with an L and a Bitcoin transition with a B. And so these things are making new UTXOs. And then like in green here, I did some weird thing that consumed a Bitcoin UTXO and consumed a Litecoin UTXO, both as inputs, and gave us some new kind of like green UTXOs as outputs. Whoops. I don't even remember what we were trying to answer, actually.
Well, I think we were talking about how, so once you've kind of merged these two chains, how do the UTXOs from, I mean, there's kind of three chains going on now, or three DAGs or whatever.
I'm trying to think of it as like three consensus metagames.
Yeah.
Well, one thing that could still happen here definitely is like, you know, this. So now we have one of those situations where like, oh yeah, so let's say some more Bitcoin stuff happens. We could, I drew that a little bit low, but you can imagine something like this is perfectly valid. But we almost have like a forking now. So like Bitcoin, so the contention is like, what happened with this UTXO?
Yeah.
And the answer is, it depends who you ask. You know, if you ask a Bitcoin miner, they're going to say, well, that UTXO got spent in this transaction right here. Yeah. But if you ask one of these like merge block people, they're going to say it got spent right here. So we can never, we can never have a chain that includes both of those blocks that I just annotated with the double lines, I guess, right? Because regardless of whether you're playing pure Bitcoin rules or like merge chain rules, you have to say, like we can, regardless of which rules you're playing, this thing can only be spent once.
Mm-hmm.
So like, I think it would be an invalid block if we tried to do something like this. Like, I don't think that's valid because, if you follow all of the parent pointers, you get back to this double spend in its history.
Mm-hmm.
This, for me, this sounds interesting because I wanted to ask you, what is for you metagame, and how is stored? Because now when you wrote this, invalid block,
Yeah.
is it the case that you can store your metagame as another labeled transition system?
Yeah. So good question. So like, yeah, I guess this is what I was thinking previously and might still work. This whole DAG that I drew here, pink, green, and blue, that's like the DAG. And in as much as I'm saying like there's a single biggest labeled transition system with all these transitions, this is like the DAG that represents those. And now that we have this DAG, now we can play consensus games on it. We can ask the question of all of the nodes in this DAG, which ones are the real ones? And answering the question of which ones count, which ones are in universe, which ones are the real ones, that's the purpose of a consensus metagame.
Mm-hmm.
And so we can have 3 of them and they can agree entirely or disagree entirely, or, agree partially, but not entirely. So like, pink and blue completely disagree about what's real. Blue says the stuff on the right is, pink says the stuff on the left is. Green has some common history with both pink and blue. But like, green is never going to come to consensus. Green has a choice to make. Green has to say, is this block in the DAG or is this block in the DAG? I mean, I guess really every consensus metagame has to make that decision, but in pink and blue metagames, it's easy because like, there's these green transitions are not even valid in their labeled transition systems.
Mm-hmm.
Uh,
Yeah, and they're only not valid because they're including like things from both of these DAGs, right?
So in this diagram, we're back to the raw transition DAG. So there's no including, these things just are transitions.
Yeah.
And so this green one, this one here, like wow, yeah, I don't know. Well, okay, right. Oh, yeah, I shouldn't be labeling edges as trans. So like this one here, I guess is what I'm trying to say.
Yeah,
this will never. This one's not valid according to the blue rules because it uses this UTXO that like, where did that come from? It's not even in our shared history, right? We don't even know what that thing is.
Yeah. Yeah. So okay. So the question that I'm asking, I guess, is so if one of these green validators were to do a pure Bitcoin transaction, so we'd have like a green Bitcoin transaction, like would an ordinary Bitcoin only miner validator, or whatever you want to call them, would they recognize that as a valid transaction?
Yeah, I think so. So let's try to do one. Whoops. You're talking about something like this. Totally. Yes. Oh, well, except I don't want to label it as an X transaction. It's a B transition.
Yeah, exactly. Yep.
Yeah, I don't see any reason why we couldn't have, let me just alter history to make this easier to draw real quick. I think this would still be perfectly valid, right?
Yeah.
Maybe a better way to do this. Okay, I think I didn't do this diagram in the smartest way. I think the entire diagram here should be in a single color with the transit. I think it's a good idea to label them. Like B transitions are Bitcoin transitions and L are Litecoin transitions. And then maybe X is something like new that we're adding. So like in our X's, ones that are like out here, I guess.
Yeah.
So now that we've drawn the entire transition DAG in the same color, the proper way to do it would be to then annotate it with like colored dots as about which metagames had included those in the like real history.
Mm-hmm.
Oh, in fact, I think I can do that really quickly. Oops. Oh no. Oh, the pen stopped working. There we go. So if I just suddenly switch that whole thing, now we can ask the question, which ones are real? And first, let's ask the Bitcoin validators. They're going to say that these ones are real, definitely. Oh yeah, and it's nice. Yeah, like now the question was, when I had this as a green block, it was like, is that still valid? Well, or block is the wrong word. Sorry, transition. It's just a transition in this DAG. And then the Bitcoin miners are coming in and putting these pink dots to decide which ones are real.
Mm-hmm.
So this is the metagame. Putting the dots on the DAG is the metagame. And then green, now that's an interesting question. I guess like probably we need these ones and all of their parents recursively. So that seems about right. And, this one probably. Okay, I think this might make sense now. So in yellow, we've got just a DAG. That's it. It's a bunch of transitions that happen, some of them before or after the other, some kind of concurrently, or we don't know the ordering. The transitions are labeled with B, L, or X, and then which ones are real is a question of what colored dots are on them and who do you trust. If you trust the pink people, you get one answer.
Mm-hmm.
I think that works. I think that's consistent.
Yeah, so I guess there's still the question of what happens when a green validator uses a pink UTXO, basically.
Yeah, so I think we were making a mistake in coloring the UTXOs. They're just UTXOs. Or maybe you're saying that uses a UTXO that comes from a transition that has a pink dot on it.
Yeah, I mean, so there are UTXOs that are recognized by the Bitcoin miners, right? And then there are UTXOs that are recognized by the Litecoin miners, or whatever you want to call it there. And then there are UTXOs that are recognized by the green miners or validators or whatever.
Mm-hmm.
And so if some activity is happening in this pure Bitcoin network and there's some UTXOs that come out of a transaction, and then one of these green validators picks up one of those UTXOs and uses it, kind of like in this Litecoin Bitcoin mixed transaction. Yeah, how do we rectify the usage of that Bitcoin UTXO with the Bitcoin network and the mixed network kind of?
Yeah, so I think that happened here. Let me choose a different non-taking sides color. I think that happened here. So there's a UTXO there that's valid according to the pink group, the only Bitcoin people.
Yeah.
And it got included in this next block, this one, which is it's also a B transition, right? So it's valid in Bitcoin rules. It's valid in this superset or this like more lenient games rules.
Mm-hmm, mm-hmm.
And so I think it's fine that those transitions be included in both views of reality, right? Those are things that we agree on.
Mm-hmm.
And only so then the question is like, when might they disagree? Well, one time when they might disagree is when the transition is not even a valid Bitcoin transition. Mm-hmm. Oh, this might get a lot more interesting if we have something like this. What I'm trying to think of is a double spend that's perfectly valid in Bitcoin. Here, maybe this is what I'm trying to do. So that's a B transition, right? That's something that's valid in Bitcoin and in our green chain, our more lenient one. But it's a double spend. And so we now have this question of like, let's say Bitcoin miners come to consensus on this one. So that means they can't have consensus on this one. Ha, whoops, took a little too much. But let's say green comes to consensus on this one. So we've had two double spends now. In the first one that we did, the one on the right, you know, like obviously the Bitcoin miners were not going to come to consensus over the one on the right ever, because it's not even it's an X transition. Like that doesn't even make sense in their consensus metagame. It could have been, I think it could have been perfectly valid that instead of the green miners choosing this one, they ended up choosing this one, but it just happened not to be that way. Now this new double spend that we've drawn, either one of this is just a regular old Bitcoin double spend, right? Like even the Bitcoin miners had the choice here. They could have chosen either one. Just happened that they chose the left one and the green miners chose the right one.
I mean, this is not the problem, right?
Yeah, what's the problem again?
The problem can be made if you want to merge these two things, but right.
If you want to merge what?
If you want to merge these two branches, but if you don't want to merge it, it's completely fine, right?
Yeah, let's I wish I had numbered the blocks. Which two might we want to merge here?
You said this latest one, like 7 and 9.
Okay.
They're representing double spend, right?
Yeah.
7 and 9.
Yeah. Yes, I agree.
You will never be able to merge it in the future.
Yeah, totally. Even apart from this multi-consensus thing, those two would never have been able to merge in the future because they're different resolutions of a double spend.
But this is completely fine, right?
Yeah, I think so. Yeah.
The network knows this, and
yeah, I think that's fine. Or in fact, that's exactly what consensus is for, right? We want to make sure that we never merge two histories that are conflicting with one another.
Yeah.
Oh, in fact, I had this little brain. Oh, I don't have Discord open anymore. I had this brain dump. So blockchains and Git repositories are super similar, right? Like we've been talking about blockchains here, but we might as well just have been talking about like a Git repo that has a bunch of branches and the blocks are commits. And when you go to merge two branches back together, sometimes auto merge works. And in the blockchain context, that's great. That just means like the blockchain keeps going, nothing contentious happened. That's like that's what the green validators would tell you happened in this block, right? Like we merged block 5 with block 13 that I'm just now labeling. It's a different color. And everything was good because that was fine by their consensus rules. But other times we might have like a contentious merge where things can't be merged back together properly. And that's when we have to have, that's when you have forks, right? That's when you have a new metagame, a new consensus metagame forming. Does that make sense? What would a contentious merge look like?
Are you saying that you can somehow fix this double spend?
Oh, interesting.
You know what I mean? You know, in this moment, we know this is double spend, but you know, if you put some other blocks, and you know, you fix all the numbers, you can say, okay, but now it's completely fine to do this transaction.
Oh yeah. You're saying like manually resolve the merge conflict, right?
Yeah, because you know it is a double spend, but you put some money on this account and you say, okay, sorry, and now it's merging again. So
oh, yeah.
I'm not sure if
So the way I was
If this
thinking of
is
that
possible.
previously is like when you go in and do a manual merge conflict, merge like, oh, I can't remember what you call it now, like manually resolve the conflicts, then there may be more than one way to resolve those conflicts. And if it's really obvious what the right way to do is, then all you've done is you've started a new consensus metagame where we say like, okay, we're allowing this one new transition that's going to manually fix this conflict. And if everybody agrees with that, great. Now we're all playing this new consensus metagame that's basically the same with just this one new transition enabled. But if it's contentious and I say like, no, I don't like the way you fixed that because I feel like I got cheated or whatever, I'm not happy with the outcome, then I might come up with a different way. And I say, how about we resolve it this way? And now we have these two new consensus metagames. Maybe we can call them like, Tomislav coin and Tomislav coin cash or whatever. But I'm actually struggling now. I can't think of how to like what a merge conflict would look like here.
Am I understand you correctly? You somehow want to create block on the red ones that will be valid, right? And also it will be accepted on the green one, right? This means resolve conflict.
Yeah, I thought when I was writing that it was a really clear notion, but I'm not so sure that it is a clear notion of like what a merge conflict would be.
So would trying to build a block that comes out of 7 and 9, would that not be some sort of conflict?
Yeah, so let's say we have a transition here. Is it a B transition?
Yeah, sure, why not?
Okay.
Yeah.
So, oh yeah, and then the question is like, yeah, okay, right, yes, exactly. So let's say someone builds that transition there. Yeah, and maybe it has some new outputs of its own. As it stands right now, neither pink nor green are going to come to consensus over that because they contain blocks that, like, pink isn't going to come to consensus over it because it contains block 9 as a parent, and they didn't come to consensus over block 9. And then for the same reasons, green says, hey, you used block 7. We don't believe in block 7. That's not part of our canon. But what might happen is that someone of, who like basically followed along with the green consensus metagame, that was their view of reality, is going to come back and say like, yeah, I definitely see that that's not valid under green rules, but it's really close. There was just this one little problem, and with one little minor modification, we could include it and continue living our lives the way we wanted to. So that's not going to be green, right? The rules of the green consensus game are established. They preclude building on block 7, but maybe like some other color that we haven't used yet, pink, comes along and so that's kind of weird. I don't know, this weird color. And they say, we've reached consensus over that. And it may be the case that the consensus diagram now looks like this. So we've got like the Litecoin rules, the Bitcoin rules, the green rules that include B, L, and X transitions. And now we've got this little thing that has the following relationship with green. It's identical, except for this one little thing that they also include that allows us to merge block 7 and 9. So one concept that I was hoping would fit in here is that chain upgrades, or like, so there's different kinds of hard forks. There's like the Bitcoin Cash hard fork that was clearly contentious, but then there's also the ones that Monero does, or now the Bitcoin Cash community does, which is like, hey, we every once in a while think of ways to make our chain better, and we need to change the rules a little bit. So let's do a hard fork there. Right? It's not contentious. All the miners update, or nearly all of them, and it just goes over like any other software upgrade almost. So I'm kind of thinking of those as being emergence of new consensus metagames, right? Like, we're no longer playing the metagame that we were playing yesterday. We're playing this different one that's like really slightly different, and it wasn't contentious, and everyone who believed in green metagame now suddenly believes in this like weird kind of dark yellow metagame.
Mhm.
Yeah, this makes sense. You're just abandoning the red ones and you're starting with new ones, right?
Exactly. And the new one captures everything that you cared about the red one, except it fixes this little thing that was, you know, maybe it was wrong all along and you're just now noticing the bug or something like, or maybe like your views have changed slightly and you've decided that actually this yellow one would be better. So yeah, like forget about green. Now we're doing yellow. And oh, and by the way, like, you know, now we get all these dots.
Yeah, yeah, yeah.
I'm starting to like this way of visualizing it, where we draw the transition DAG and then put dots on it for different
Yeah,
concepts.
yeah.
Yeah.
Oh, yeah, that's really an interesting example because the 7 and 9 block came from a clear double spend.
Yeah, right, exactly. Yeah. Well, that's why we had pink on 7 and green on 9 in the first place, right? Like they
Yeah.
both said like, okay, here we are. We have to choose one or the other, and they happen to choose different.
Hmm.
So yeah, that's like, I don't know if that totally makes sense or not, but I think we got some interesting ideas.
Yeah. Yeah. I was wondering what the actual resolution is there then to build that latest block.
Yeah. Yeah, right. Maybe it's maybe the resolution would be something like this, where we consume all of the outputs of block 7 and throw them away because they contain, I don't really know. Yeah, I'm not sure.
Yeah.
That seemed like a good idea at first, but then I realized like a much simpler solution that doesn't involve a new metagame would just be going back to 6 and saying like we're still building around 7.
Mm-hmm. Mm-hmm.
Oh, or maybe, okay, maybe what this is that the pink people and the green people know that they have this consensus relationship, and they like working together, and you know, it's understood that pink will never come to consensus over any of these X transitions or L transitions, but to whatever extent it's possible, they want like to still be compatible with the green people. And so they realize like, oh no, block 7 and 9 is a case where we diverged and we didn't have to. You know, we just happened to like our consensus games came out differently there. Let's go back and like fuck block 7. Like pink people are now yellow, and they're just going to choose block 9 instead, or something like that.
Mm-hmm.
Well, maybe that's enough of thinking about that for today, or we should let the gears turn. How are you guys feeling?
Yeah, I guess it's kind of late.
Pretty low.
Okay, yeah, cool.
So, yeah.
Well, guys, thanks so much for listening to to me talk about this. I'd love to hear feedback if you start to think about it more or have other ideas or whatever.
Cool.
Yeah.
Oh yeah, definitely. It was very interesting. Yeah.
Yeah. Thanks for presenting.
I will try
Thank
to.
you, everybody, for joining. I'm going to stop the recording now.
Cool.
Do I stop it or pause it? I guess stop it. Okay.